The car industry is changing. The shift towards more sustainable and eco-friendly solutions is more evident than ever. Traditional gasoline and diesel engines are being phased out in favor of greener alternatives. This transformation is not just a trend, it's a necessity driven by the urgent need to combat climate change and reduce our carbon footprint. Battery electric vehicles, or BEVs, are everywhere. From city streets to suburban driveways, these silent, zero-emission vehicles are becoming a common sight. Governments around the world are incentivizing their adoption, and manufacturers are racing to meet the growing demand. Charging infrastructure is expanding rapidly, making it easier than ever to own and operate an electric vehicle. But Toyota, a giant of the automotive world, is taking a different path. While many of its competitors are fully embracing electric vehicles, Toyota is exploring alternative solutions. The company has a long history of innovation and is known for its cautious yet strategic approach to new technologies. They are sticking with what they know best: internal combustion engines. But there's a twist. Instead of relying on traditional fuels, Toyota is experimenting with hydrogen as a cleaner alternative. This approach leverages their extensive experience with combustion technology while addressing the environmental concerns associated with fossil fuels. Toyota is betting big on hydrogen. The company believes that hydrogen fuel cells and hydrogen combustion engines could offer a viable and sustainable solution for the future of transportation. Hydrogen, when used as a fuel, produces only water vapor as a byproduct, making it an incredibly clean energy source. They believe this technology will revolutionize the way we drive. Hydrogen-powered vehicles could provide the range and refueling convenience of traditional cars while eliminating harmful emissions. This could be particularly advantageous in regions where electric vehicle infrastructure is still developing. Toyota's CEO believes this is a pivotal moment. He envisions a future where hydrogen plays a central role in the automotive industry, complementing electric vehicles and providing consumers with more choices. This vision is backed by significant investments in research and development, as well as partnerships with other industry leaders. He sees hydrogen combustion as a game changer, potentially even bigger than the hybrid revolution started by the Prius. The Prius, which debuted over 2 decades ago, was a groundbreaking innovation that paved the way for the widespread adoption of hybrid technology. Toyota hopes to replicate this success with hydrogen. It's a bold move, a gamble against the prevailing electric tide. While the majority of the industry is focused on battery electric vehicles, Toyota is charting its own course. This strategy is not without risks, but it also holds the potential for significant rewards if hydrogen technology can be successfully scaled and adopted. But Toyota has a history of proving doubters wrong. From the introduction of the Corolla to the success of the Prius, the company has consistently demonstrated its ability to innovate and lead. As the automotive landscape continues to evolve, Toyota's commitment to hydrogen could once again set it apart as a pioneer in the industry. Toyota is known for its reliable cars. Their engines are legendary for their durability. This focus on dependability has been key to their success. It's what has made them a global leader in the automotive industry. Now, Toyota is applying this same philosophy to hydrogen technology. They see hydrogen combustion engines as a natural evolution of their expertise. By adapting familiar technology, they aim to ease the transition for consumers. They want to offer a familiar driving experience with the added benefit of zero emissions. Hydrogen is the most abundant element in the universe. It's also incredibly clean. When used as a fuel, the only byproduct is water. This makes it a very attractive alternative to fossil fuels, which pollute our planet. Compared to battery electric vehicles, hydrogen offers some advantages. Refueling is much faster. There's no need to wait hours for a battery to charge. Additionally, hydrogen vehicles can potentially offer a longer driving range. This is particularly important for larger vehicles like trucks and SUVs. Toyota isn't the first company to explore hydrogen combustion engines. In the late 1990s and early 2000s, BMW experimented with this technology. They even produced a limited number of hydrogen-powered 7 Series cars. However, BMW faced several challenges. The technology was still in its infancy. The hydrogen infrastructure was practically non-existent. This made it difficult to refuel these vehicles. As a result, BMW's hydrogen project never gained traction. Toyota has learned from BMW's experience. They've spent years developing their hydrogen technology. They've also invested heavily in building a hydrogen infrastructure, making it easier for people to refuel their hydrogen-powered vehicles. Toyota currently has two hydrogen combustion engines. The first is a 1.6-litre turbocharged three-cylinder engine. It's based on the engine found in the sporty GR Yaris and GR Corolla models. Despite running on hydrogen, it retains the same character as its gasoline counterpart. The second engine is a more powerful 5.0-litre V8. This engine is designed for larger vehicles such as pickup trucks, SUVs, and sedans. It's based on the engine found in the Lexus RCF sports car. These engines demonstrate Toyota's commitment to offering a range of hydrogen-powered vehicles to suit different needs and preferences. Section 6. Adapting to hydrogen engineering ingenuity. Converting a gasoline engine to run on hydrogen is a complex process. It requires significant modifications. Engineers must meticulously plan and execute each step to ensure the engine runs efficiently and safely on hydrogen. This transformation is not just a simple swap of parts, it involves a comprehensive overhaul of various engine systems. For starters, the entire fuel system needs to be redesigned. Unlike gasoline, hydrogen is stored and delivered in a gaseous state, which means the fuel lines, injectors, and storage tanks must be capable of handling high-pressure gas. This requires precision engineering to prevent leaks and ensure the system's integrity. Hydrogen is stored as a gas under high pressure. This necessitates the use of specialized storage tanks that can withstand the immense pressure without compromising safety. These tanks are often made from advanced materials like carbon fiber composites to provide the necessary strength and durability. This requires specialized tanks, pumps, and injectors. The fuel pumps must be capable of delivering hydrogen at the required pressure, and the injectors must precisely control the amount of hydrogen entering the combustion chamber to ensure optimal performance. The ignition system also needs to be adapted. Hydrogen has different combustion properties compared to gasoline, which means the ignition timing and spark intensity must be carefully calibrated. This often involves replacing standard spark plugs with ones specifically designed for hydrogen combustion. Hydrogen burns differently than gasoline, requiring different spark plugs for efficient combustion. These spark plugs are designed to provide a more intense spark to ignite the hydrogen-air mixture effectively, ensuring smooth and efficient engine operation. Additionally, the engine control unit, or ECU, needs to be recalibrated to optimize performance and fuel efficiency. The ECU controls various engine parameters, and recalibrating it ensures that the engine operates efficiently with hydrogen fuel, providing the best balance of power and economy. Finally, some structural changes are necessary. Hydrogen combustion can produce higher temperatures and pressures than gasoline, so the engine components must be reinforced to handle these conditions. This may involve using stronger materials or redesigning certain parts to improve their durability. Hydrogen is a very reactive element. Handling it safely requires strict adherence to safety protocols and the use of specialized equipment. Engineers must ensure that all components are compatible with hydrogen to prevent any chemical reactions that could compromise safety. To ensure durability and safety, some engine components need to be made from more robust materials. These materials must withstand the high pressures and temperatures associated with hydrogen combustion, ensuring the engine remains reliable and safe over its operational life. Section 7: Hydrogen's hurdles, production, storage, and safety. In this section, we will delve into the complexities and challenges associated with hydrogen as a fuel source. From its production to its storage and the safety concerns that come with it, hydrogen presents a unique set of hurdles that need to be addressed for it to become a mainstream energy solution. While hydrogen offers significant advantages, such as being a clean and efficient energy carrier, there are still numerous challenges to overcome before it can be widely adopted. These challenges span across various stages, including production, storage, and safety measures. One major hurdle is the production of green hydrogen. Green hydrogen is produced through the process of electrolysis, which involves splitting water into hydrogen and oxygen using electricity. The key to making this process environmentally friendly is to use renewable energy sources like wind, solar, or hydroelectric power. Currently, most hydrogen is produced from natural gas, a process known as steam methane reforming. This method is cost-effective but has a significant downside. It releases large amounts of carbon dioxide, a greenhouse gas that contributes to climate change. This makes the current hydrogen production process less sustainable. Green hydrogen produced through electrolysis using renewable energy is more environmentally friendly but also more expensive. The high cost of renewable energy and the electrolysis process itself make green hydrogen less competitive compared to hydrogen produced from fossil fuels. This economic challenge is a significant barrier to the widespread adoption of green hydrogen. Storage is another challenge. Hydrogen needs to be stored under high pressure, which requires strong and bulky tanks. These tanks are not only expensive, but also take up a considerable amount of space, making them less practical for certain applications, such as in vehicles where space and weight are critical factors. These tanks take up space and add weight to the vehicle. This added weight can reduce the overall efficiency of the vehicle, as more energy is required to move the additional mass. Moreover, the design and integration of these storage systems into vehicles pose engineering challenges that need to be addressed. Finally, safety is a concern. Hydrogen is highly flammable. The storage and transportation of hydrogen require stringent safety measures to prevent leaks and accidents. Even a small leak can lead to a significant hazard, as hydrogen can ignite easily and burn with an almost invisible flame. Leaks or accidents could potentially lead to fires. Emergency response teams need to be specially trained to handle hydrogen-related incidents. The development of robust safety protocols and technologies is essential to mitigate these risks and ensure the safe use of hydrogen as a fuel. Section 8. Toyota's Solutions. A multi-pronged approach. Toyota is actively working to address these challenges. They believe that as the use of hydrogen expands across various industries, production costs will decrease. This is known as economies of scale. To improve storage, Toyota is exploring alternative methods, such as using ammonia as a hydrogen carrier. Ammonia is easier to store and transport than pure hydrogen. To ensure safety, Toyota is implementing rigorous safety protocols in their vehicles and at refueling stations. This includes leak detection systems, pressure relief valves, and robust tank designs. Section 9. Hydrogen's Future, a promising contender. Hydrogen has the potential to play a significant role in the future of transportation. It offers a clean and efficient alternative to fossil fuels. While challenges remain, Toyota is confident that these can be overcome. The next decade will be crucial for hydrogen technology. If companies like Toyota can successfully address the remaining challenges, hydrogen could become a mainstream fuel source, powering our cars, trucks, and even our homes.